All right, so we are going to be doing our review right now. This is the quiz number 10 review. Actually, I think this is quiz number 9. I mislabeled that. Let me change that because normally we were supposed to do the midterm week 9, and then the quiz was supposed to be week 10, but we flipped it, okay? Because they didn't want us testing during the WASC visit. So we had to kind of flip it over. So this is quiz number 9. I think I wrote it correctly on the board over there, but not on my write up here. So this is quiz number 9, and it's only over 3 sections. Okay, 10.2, 10.3, and 10.4. So let's review these things. I think we have 6 examples or 7. They don't take too long, thankfully. But we have find the value of the trig function. Okay, tangent of theta. What is the value of tangent of theta? So remember, for tangent, we need opposite over hypotenuse, right? Oh, sorry, opposite over adjacent. Thank you very much. Who is that? That was okay. Got to give you extra credit for that. Okay, I was thinking sine. So opposite over adjacent. Okay, now I have to make sure I have opposite and adjacent. So here's my angle. Okay, what side is my hypotenuse? The 15. Which one's my adjacent side? The 12, right? That means opposite is up here, and I don't have it, right? But I need to write my answer for tangent of theta. It's going to be a fraction. So I'm going to have to figure it out using the Pythagorean theorem. Okay, this was section 10.2, by the way. If you're wondering, when did I do that? That was section 10.2. So we're going to use this definition, a squared plus b squared equals c squared. Remember, the letter c is always your hypotenuse, right? A and b can be either one of the legs, but c has to be your hypotenuse. So I'll let 12 be a, just because I want to. It doesn't really matter. It could be a or b. And then c has to be 15. So 12 squared is 144 plus b squared equals to 225. Okay. Now, if I subtract 144 over to the right side, remember when you move it from one side to the other, it changes sign. Okay. So this is b squared equals to, and 225 minus 144 is going to give you 81. So if I take the square root of both sides, I get that b is equal to 9. So b, oops, I put the letter b there, sorry. The opposite side is 9. So now I can put my fraction there, okay? That means that tangent of theta is opposite, which is 9, over adjacent, which is 12. Now, if you can reduce, please reduce. So I can reduce this by 3, right? 3 goes into 9 3 times, and 3 goes into 12 4 times. So this answer, tangent of theta, is 3 over 4. Okay? Now, if you're wondering, why didn't we solve for the angle? I didn't ask for the missing angle, right? I said, figure out the value of the trig function. I didn't ask you for the value of the side. I said, figure out the value of the trig function. That's the difference between these sections. 10.2, we're writing fractions for the trig function. In 10.3, we're finding out sides. And in 10.4, we're figuring out angles. Okay? That's the difference.
Will it say like when it says like on the quiz when it says like find the value of the trig function? Will it give you like find for like tangent or find for sine?
For these, it will tell you tangent, sine, cosine. Yeah, these will definitely give you a specific thing to do, like here, right? It's already pre-written, cosine, sine. So you'll know you got to solve those. Yeah, in section 10.4, like you had to figure that one out, right? You were given stuff, you figured out what you had, and you used what the trig function that worked. So for question number 2, again, we have another right triangle here with the side of 5 and 13. We have an angle theta, but they want me to find cosine of theta, okay? And remember, for cosine of theta, that's equal to adjacent over hypotenuse, okay? Adjacent over hypotenuse. So I'm going to kind of hone in on my angle here, all right? Which one is my hypotenuse for this one? 13. Which one is my adjacent? That's opposite. Yeah, adjacent is right here. This is opposite though. 5 is my opposite. Remember, adjacent, the little arc touches the adjacent and the hypotenuse all the time. So one is going to be adjacent, one's going to be hypotenuse. So I need to figure out my adjacent side. Okay, I got to figure out that a value. So again, we're going to use the Pythagorean theorem, right? So we have a squared plus b squared equals to c squared. So since the first time I used a as my number, I'll use b as my number this time. We'll solve for a. Again, it doesn't matter. If you want to always solve for b, go ahead, unless a and b are both given. But in this case, one of my sides is a 5. So let me write a squared plus 5 squared equals to 13 squared. Remember, the hypotenuse is always c. Again, you could have put the 5 where the a is and left it as b squared. It doesn't matter one bit. So we have a squared plus 25 is equal to 169. If I subtract 25, a squared is equal to 144. Okay? If I take the square root of both sides, the square root of 144 is 12. So that means that my adjacent side is 12. So now I can write my ratio, right? I can write the ratio for my trig function. So cosine of theta is equal to adjacent, which is 12, over the hypotenuse, which is 13. I cannot reduce that, so I'm just going to stop right there. Again, these answers, don't write them in decimal form, okay? We want, when they ask you to define the value of the trig function, they're talking about ratio values, okay? Ratio values, so fractions, okay? Some student once asked me, why do they say ratios are fractions? And I'm not saying that this is the case, okay? But this is just something interesting that I've noticed. The word is in the word fraction, right? I don't think that that's the reason why it's defined as that, but that helps me remember why a ratio is a fraction, because ratio is in a fraction, right? So, not that you need to write that down or memorize. It's just that's the way I remembered it when I was younger. I used to always say, like, what is the ratio again? Then I thought my teacher would say fraction. I'm like, oh, that's right. There's ratio in fraction. So that's what it is. All right, last one of these, and then we'll move on. But these are still the same thing. We're just doing sine, cosine, and tangent, right? So this one's for sine of theta. We have another right triangle here. There's a 90-degree there. That's how we know it's a right triangle. Here is my angle that I'm going to highlight, okay? I know that my hypotenuse is what? 25. My adjacent side is here, unknown, and my opposite side would have to be 7. Now, sine of theta is opposite over hypotenuse. Do I need to figure out my adjacent side? No, right? I need O and H. I have O and H. So for this one, just write down what you got. O is 7, H is 25, and you're done. So the reason why I wanted to do this one is because you don't always have to use the Pythagorean theorem to solve these problems. Sometimes they give you exactly what you need, so you just use it, okay? Other times you may have to solve for other stuff, okay? But for sine of theta, I just needed opposite and hypotenuse. They gave me opposite and hypotenuse, so I don't need to solve for adjacent. There's no need, okay? Now, if the question would have said, here's a triangle, find every single value for sine, cosine, tangent, then sure, I'd need all three sides. But we're good with this one. We don't have to do anything extra. All right. So for number 4 and 5, I think, yeah, it's just two of them here. These are finding the measure of the side. Okay, how long is a specific side? Okay, so this is not going to be a fraction. Okay, the fractions only come out when they say what's the sine theta equal to, what's tangent theta equal to, etc. This is a specific side value that they want. Okay, so we are still going to use sine, cosine, and tangent, but we're just going to be solving for a missing piece. And remember, I think when I taught it to you guys, I told you there's an easy way and a hard way. The easy way is when the variable is on top of the fraction. The quote-unquote hard way, not that it's definitely hard, but it takes a little more time, is when the variable is on the bottom, okay? So I have triangle ABC. It is a right triangle. I have a value of 9 in x. I could care less about side AC. It doesn't say anything there, but I don't need it, okay? Let me highlight the angle here by using an arc. All right, what's my hypotenuse? 9. So that makes x what? Adjacent, right? I don't need to know what the AC side is. There's nothing there, so who cares? What deals with AH? Cosine. So cosine of theta is equal to A over H. That means that cosine of theta is X over, oh, I'm sorry. Yeah, I just saw that I forgot to put cosine of 51. Cosine of 51, okay, is X over 9. Okay? I forgot that we had the angle given when I wrote it out. So this is what we call the easy method, the easy way to doing it, right? Because all I got to do is move the 9 to the left side by multiplying and then just use my calculator. So let's go ahead and do that. Let's get this 9 and multiply it over to that side. So it's going to be 9 times cosine of 51 degrees is equal to x. Okay? By the way, one of your jobs is going to be when you guys grab a calculator, and you might want to check right now, make sure that there's a letter D on there, okay, on the very top. All right. Make sure it says degree. It's kind of small, but because if it doesn't say the letter D, your answers, they're not going to look wrong, but they're going to be wrong because you're in the wrong form. So I'll try to remind you guys of that. There's a quick way to fix it, just in case you're not sure. You press Shift 9. So if you press Shift 9, you see that it says clear, right? And then you press 3 to clear all, hit equals, and then AC. And that clears all memory and puts everything back into normal form, which is degree mode. Okay? Because some students will like press every button, right? They'll do this before they turn the calculator in, and then there's like all these weird modes activated, right? So when you can reset it if you want to. So if you're during the test, if you want me to check that your calculator is okay, just raise your hand. I'll go check it for you. Okay. So anyway, we're gonna do 9 times cosine of 51 degrees. That gives me 5.663. I didn't tell you what to round it to, but let's do the nearest hundredth. That's 2 numbers over. Okay. So x would be what, 5.66 if we do to the nearest hundredth. Okay, 5.66, because the number after the 6 is a 3. The 3 does not make that 6 into a 7. So there you go. So this one's considered the hard, well, I figure, I haven't done it yet, but I'm thinking this is going to be the hard type of problem. Okay, so we have another triangle, ABC. We have a side that's 13, a side that's x, one unknown side. We have an angle of 26. Okay, an angle of 26. So for this problem, we have to label our sides, right? So looking at this triangle, my hypotenuse would be what? The empty one. Yeah, it's this one right here, right? And then my adjacent would be x. That makes 13 my O. But since H has nothing there, I'm going to erase it. I don't need it. So which one has OA? Tangent. All right. So tangent of theta is equal to opposite over adjacent. So tangent of 26 degrees is opposite, which is 13 over adjacent, which is x. This is what we call the harder problem because the variable's on the bottom. It's not that big a deal, but it does require 2 extra steps. Okay. So I'm going to move the x over to the left side, okay, by multiplying. So that's going to be x times tangent of 26 degrees is equal to 13. And then I'm going to divide it on both sides. The tangent of 26, I'm going to divide it on both sides. So tangent of 26 degrees on both sides. So on the left side, it's going to cancel. All you're left with is x. On the right side, just calculate 13 divided by tangent of 26. So 13 divided by tangent of 26 is equal to, again, I'm going to round it to the nearest hundred. So it's 26.653. So it would round to 26.65. Now, if you're wondering why I don't put degree symbols on this, it's because this is not an angle. This is a side, right? These last two answers were sides. So, all right, I think we got two more, but now we're switching to the last type of section, finding the angle measure. Are we okay so far? Questions 1 through 5? Any questions on this? This one, again, finding a missing side. Okay, that's what 4 and 5 was. 1, 2, and 3 was all about finding the ratio for sine, cosine, and tangent. What fraction represents sine, cosine, and tangent? Okay, which does require you sometimes, because you'll see this one didn't require the Pythagorean theorem, but sometimes it will require the Pythagorean theorem, the stuff in Greek. Okay, so make sure you remember that. I heard one of my students in 5th period yesterday say, she said, I know how to do the work. I just have to remember to memorize the sine, cosine, and tangent definitions. So the only thing she's struggling with is memorizing which one is what. But once she knows which one to use, she does just fine. She can't remember what sine is defined as, right? So make sure you guys memorize that. Spend a little bit of time doing that. All right, so this one is find the measure of the angle that's indicated to the nearest tenth. Okay, so we have a number 6 right here. We have a right triangle again. Our angle is theta. I'm going to kind of put a little mark there. Okay, we have a side that's 7, a side that's 8, and then an unknown side, which means probably don't need to worry about that one. Okay, and I'm going to start labeling stuff. So do I have a hypotenuse? Which one is it? 8. All right. Do I have an adjacent side? Well, I do, but it doesn't have anything, right? And that means that 7 is my opposite, right? So I'm going to get rid of the A there because it doesn't have anything. So it's just OH. So that's going to be sine, right? So sine of theta is opposite over hypotenuse. And this one, like to kind of go with what Corey said, are they going to tell me which one to use? These ones, they won't. Okay, you have to figure it out by seeing what you're given, and then you decide it's this one. Okay, whereas the first 3 examples, I did definitely tell you got to do it this way, right? So, all right, so sine of theta, which I don't know what theta is, we're trying to figure that out, is equal to 7 over 8. Okay, so remember, to solve for the angle, you're just going to transform this equation into theta equal to sine inverse of 7 over 8. And then you're going to punch it into your calculator, right? So you're going to hit shift sine, that's for sine inverse, 7 over 8 is equal to, and they want the nearest tenth. What's my answer to the nearest tenth? Well, I'll write it right here in case you don't have it. This is what I get. So what's the nearest tenth? 61.0 or just 61, right? Because, I mean, you don't have to put 0.0. That doesn't mean anything. And then I got to put degrees on it, right? So 61 degrees. So there's one more of these that we're going to do, and then that's basically going to encapsulate your whole quiz. I don't think the quiz is truly that difficult, but you better know your definitions, right? If you don't know your definitions, to use your words, yeah, you're cooked, right? So without definitions, you're not going to be able to do this stuff. Okay, so please make sure you spend a little bit of time, at least in between your rounds of Call of Duty, right? Once you lose, you got a little while spectating. Pull out your math notes, start reviewing, right? So this is going to be our last problem. Yeah, this is the last one. So we have another right triangle. Notice every one of these has been right triangles because these definitions we're using only work for right triangles. There are other definitions that work with other triangles. So for example, I could solve non-right triangles using, like, here's one equation. C squared is equal to A squared plus B squared minus 2AB cosine C. There's one equation that can solve one triangle that doesn't have a 90-degree angle. And there's 3 of those versions, right? There's other versions for areas and stuff, but we're only doing the easy ones, the right triangles. Okay, so here we go. We're going to solve for that angle. Do I have a hypotenuse for this one? It's 4. Thank you. Do I have an adjacent? That's 3. And I have an opposite, which is AC, but I'm not going to write it because I already found my 2 pieces that I need, right? They both have numbers on them. So I don't need to put a 0 or an O and then erase it immediately, right? So AH is what? Cosine, right? Cosine theta is equal to A over H. That means that cosine of theta is equal to adjacent, which is 3, over hypotenuse, which is 4. We're going to solve for theta, so we're going to rewrite this thing as theta equal to cosine inverse of 3/4. At this point, you're going to hit shift cosine 3 over 4 and hit enter, and we get 41.409. If I'm rounding to the nearest tenth, what do I get? 41.4. What if I was rounding to the nearest hundredth?
41 or 41.4.
Yeah, 41.41. That's what I get. But the nearest tenth is 41.4. Okay? And that's degrees. Okay? So there you go. So this is what you guys need to know for tomorrow. Calculator heavy, right? Calculator heavy. You're going to need your calculator for this.